share the screen.
Mhm. Greetings, everyone. Thank you for making the time to join with us. Okay. Greetings, everyone. Thank you for making the time to join with us tonight. Welcome to our webinar on applying electrical engineering and computer science to the humanities, organized by IEEE Just Student Branch and IEEE Prime University Student Branch. I'm Ratul Hassan, currently working as the graphic designer at IEEE Just Student Branch, and I'll be your host for the rest of the event. We are honored to have Dr. Elisa Barney Smith as the speaker tonight. She's a professor at University of 22 years at
Still there?
Ratul, please unmute yourself.
Oh, I'm very sorry. I'm very sorry. Okay. Can you hear me now?
Yes, you're
Yeah.
clear. Yeah.
Thank you. Greetings, everyone. Thank you for time to join us tonight. Welcome to our webinar on applying electrical engineering and computer science to the humanities, organized by IEEE Just Student Branch and IEEE Prime University Student Branch. I'm Ratul Hassan, currently working as the graphic designer at IEEE Just Student Branch, and I will be your host for the rest of the event. We are honored to have Dr. Elisa Barney Smith as the speaker tonight. She is a professor at Luleå University of Technology, Sweden. She specializes in image processing and machine learning. She has a bright career of 22 years at Boise State University. She is an active IEEE member and past chair of global committees. And she is also an IEEE distinguished visitor since 2023. That was very brief introduction to her. We are very glad to have you again.
Thank you for inviting me.
To everyone joining with us tonight, we have already selected some questions that you have submitted in the time of registration. However, if you have any more questions or need clarification about anything discussed in this event, please write them down in the comment section of Facebook Live or chat section of Google Meet. We'll try to touch on that in the Q&A section. Now I'll hand things over to Dr. Smith. Whenever you're ready, Professor.
Okay. Well, then let me see if I figure out share my screen. There we go. And entire screen. In there. How's that? And just a second. Can you see my presentation okay? And can you hear me?
Yes, you are clear and can
Okay.
hear you.
Well, thank you very much for inviting me to speak with you. This is a presentation I've given several times and to several groups, both students and professionals, and the feedback has always been very positive. I like it because it's something which I have found very interesting, and I'm very happy I had the opportunity to come into this. And I've titled it Applying Electrical Engineering and Computer Science to the Humanities. A short background about me, as was mentioned, I spent 22 years at Boise State. I'm originally from upstate New York, northern New York, in the East Coast of the United States. And then I moved out to Idaho to Boise State University, where I was a professor for 22 years. And then a really wonderful invitation came to me, and I moved to Sweden, to northern Sweden. So I'm at about 65 degrees north latitude, almost the Arctic Circle. About 100 kilometers north of me is the Arctic Circle. And so right now it's only 4:30 in the afternoon, and it's been dark for an hour already because we are nearing the midwinter. But I love it here. It's been a very nice place with giving me lots of opportunity to do wonderful things. And we have our logo for the university, which is ice cubes because of our northern latitude. So my talk is about what is electrical engineering and what electrical engineers do, because I was always asked this quite often when I was a professor at Boise State. You get incoming students, and the incoming students want to know, what is it that I'm going to be able to do with my career? So things that we would show them would be things like electronics and semiconductors. The city of Boise had Microtechnologies, which was a very big semiconductor producer, makes a good amount of the world's DRAM chips, and there's other sector processing in the state of Idaho as well. And I'm sure that you, as you chose your major, are aware that electronics and semiconductors are a large part of electrical engineering, and that those are often used in construction as well. So you can, on the bigger side, rather than just manufacturing the chips, you can put them together to make all sorts of.
I'm sorry for interruption, but are you presenting the slide?
Yes, I asked you if you could see it.
Sorry, we cannot see the presentation. We can see you, but we cannot see the presentation.
Okay, I tried to share it. Share screen, that screen, share. It says, can you see my preview?
Yes, now we can see that.
Okay. So from New York to Idaho, east to the west coast, and then to Sweden in the north. And we're the ice cubes up the north. Electrical engineering, electronics, and semiconductors. And that's a big part of what things do. But in addition to making the insides, we can put them all together to make consumer electronics. There's lots of different electronics which electrical engineers contribute towards building. It's also relatively well known that electrical, even though a lot of people before the university think electronics is all mechanical engineering, a good amount of it is electrical engineering and computer science for how do you control and use those robotics. Biomedical engineering is starting to get into the part of electrical engineering that's a little bit less known to the general public, but we build a lot of things which contribute to the health of people around the world. Communications, we take that for granted, but that's another big area for electrical engineers, and we wouldn't be anywhere without that. I would not be talking to you today if we didn't have all these great developments. And the oldest part of electrical engineering, the reason that IEEE was started was because of power distribution, and then that has moved from the old-fashioned power distribution all the way up into smart grids. So that's another big part of electrical engineering. Now I'm in a machine learning artificial intelligence group at Luleå Technical University. And some of the things which we think about applying machine learning and AI to, there's lots of them that can be applied to all sorts of different things. But when we take what we've already thought about for electrical engineering and the things which are commonly known for AI, there's something missing. And that's the humanities, because that's the part that's not really thought about, is how can we apply electrical engineering and computer science outside of the technical fields? And that's what I'm here to talk to you about today. A little bit of background about how I got where I'm at. I'm in the field of document analysis. From years, layout, learning in another. Then we have that in a library. Go to your national library, and there's a lot of books and a lot of paper that have been digitized. But just those images don't do you a lot of good. What we really want to do is we want to take those images and convert that image into text, where we now know what those letters are, and therefore it's now machine searchable. But in addition to the text, we can then add some style information. And that was their way of predicting the numbers. But we've come a long ways from predicting numbers to predicting letters, and we can apply it to recognizing all sorts of different types of documents. And here's a bunch of assorted modern day documents from pages in books, magazines, technical articles, newspapers, and business receipts. Lots of places where we can recognize the characters. And here things are machine printed. But there's also handwritten documents. And as a field, once we get good at something, engineers, we like challenges, so we move on. And here's a bunch of handwritten documents in several different scripts, starting with the Latin script used for English to a different type of script used for German a century ago, an Indic script, Bangla, Chinese, and this very last one is a cyber script used to encode and hide information centuries ago. So it's not really a real script, it's totally made up just to send a secret message. A lot of the historical documents I work with are written by scribes. The one in the middle is actually printed to look like a scribe, because it's a little bit newer, right after Gutenberg invented the printing press. And those are really pretty to look at and a lot of fun to work with. But they include a lot of really challenging words trying to extract what those letters are. So the field of digital humanities was born, where we try and merge the studies in the humanities with the technical abilities of computing and related disciplines. And I'm going to talk to you about 4 main projects that I've worked on in the digital humanities that I found very interesting and that were very fun to work with. But there's several others that I've worked on that I'm not going to talk to you about today. So it's not just that digital humanities or my work fits just these 4 topics. There's really a lot more. The first one, Melville's Marginalia, really is a project led by my partner. And all of these projects, if they're in the humanities, I find are very best when they're led by the people in the humanities who know what information they want to get out. And then we provide our services and we develop new techniques around their research questions. So I'm not sure if you really know who was Herman Melville. He's from the 19th century, and he's most famous for writing a book about a big white whale. And people are out hunting whales in the 19th century. He was born in 1819, and when he was 12 years old, his father died. And a century ago, or 2 centuries ago now, that was really bad if the father died, because he was the only one earning money for the family. So he had to stop going to school, and a few years later, he went to sea to try and earn some money, became a sailor hunting whales. And then from his experiences, he was able to write a book, which was very, very popular, about some of the stuff in some of the islands in the Asian oceans. That was so popular, he wrote another one to go with it, and that also was popular. And then he started writing several other books before he wrote Moby Dick, and they were a little bit less popular because he started getting a little bit too theoretical for the general public. People who were buying books were just looking for something fun to read in the evening and the weekends. He kept writing, and the books didn't sell very well, and his last book was written in 1857, and then he turned to doing some other things to earn money. Books were not like today in Amazon, where you can get books at any time. If they were not being sold, the books were not printed. Printers only printed a few of them at a time, and you had to buy them directly from the printer. So by 1876, you couldn't buy his books except for a used book from somebody. And then he died several years later after his books had been out of print for quite a long time, and people had kind of forgotten about him. And so when he died, his wife had all the books that he had owned, which he'd used to teach himself when he was no longer able to go to school, and all of the manuscripts he'd written as he was writing his books. And so what was his wife going to do with all these things when he was dead? She sold the books, and she threw away the manuscripts. But then several years later, as people were really starting to look at American literature from a scholarly perspective, they wanted to know more about him. They said, these books, which have been forgotten, were really the first really American literature. And they wanted to know more about who he was as a person and what inspired his writing and how did he go about coming up with these ideas. But we have those books he once owned, and in those books, he actually tended to write in those books, even if he borrowed them from a friend, and he'd write notes. And these we know are things which he found interesting or ideas he was coming as he was reading the text. We know that original book on the cleaning of his history. We've been tracked down 500 of those books, knowing that they still exist someplace. And then we know that he also borrowed several books from his friends and from libraries, like the New York Library. So after studying things for about 100 years, people came up with a list of the books that he owned, and made a list, and another list, and finally another list, which this list then took the name of Seals. And all these lists were just handwritten or typewritten. And as the books were found, they were added to it until 2006, when those typewritten lists suddenly became an odd list because we had internet. And then the Melville's Marginalia website came about another decade after that, where instead of just a list of the names of the books, we had line images of the pages of the books as well. And that website still exists today, and all of you are welcome to go to that website. It's open to the public as well as to scholars. And in that web page, you can find those books, not all of them, they're not all up there yet, where you can find any of the books that he once owned, and in those books, you can look at the individual pages, including the page, and you can study them just like anybody else can. And in those books, we've got the marginalia, and I got brought into this project to help OCR the printed text that's there with the marginalia. We then use this to say, well, okay, here's the mark he made, but what are the words that he was marking as he was reading that book? What are the words that he was underlining as he was marking it? Because these are the words that were inspiring him. And so we've taken that to try and say, well, what did he read? What did he really read very closely? Because those are the words he marked. We know that. What did he comment to himself? We've got a lot of those information too, because we can read the marginalia stuff he put there. But we're now trying to figure out, how did that affect his writing? How can we correlate what he was reading and commenting to what he was actually writing in the books he wrote? And some of that comes through the OCR process, and then getting the XML for those pages, seeing what words were frequently there, and then doing some analysis of writer style and source text. So here's a little bit of a page, and we can see the XML where we can see the mighty storm are these words, and we know where those words in the different lines. And we can take the words that he marked up, and we can add extra information to it. And this information now is all available. And with that, we can say, what are the frequent words? Word clouds, I'm sure you've seen them before. They look pretty way to describe things, but we really want to take these words and say, well, what do we understand about these words? Love, knowledge, man, those are some of the words that were inspiring him. What do we know about those words, and how did those words influence him? But those words alone don't help. We need to know, what did he love? And so we look at the words that were associated with those words, and looking at bigrams, 2 words, and how those different words that were most common are related to each other. Which ones of those common words are closest to other ones? We can see which books he marked up more frequently and which chapters in various books. So here's some books by William Shakespeare, and we see that he did a lot more marking in Antony and Cleopatra. So that was something which was very much of interest to him. So we can then start to hypothesize how that's affecting his writing. And a lot of that's really done by closely reading and looking at the notes of the books he read and the books he wrote. So here's an example of a book he read. It's more of a scientific book about whales. Here's an excerpt from a book he wrote, that famous Moby Dick book about a whale. And we can see certain words that are common. The word gurgle, from your knowledge of English, you know is not a very common word. But the fact that it occurred in two places might mean that there's a correlation, that he chose to use it in his writing because he read about it as he was researching scientific information about whales. And on that scientific page about whales, there is actually that word gurgled. And if we do some image processing, there's some erased text there. We're not sure exactly what it says. We can read some of those words, but not quite all of them. But let's take that and consider that. We know he wrote these words in the margin. Well, maybe those unread words could be these words here. And then in the editing process, you know that when you write something, you write it and you rewrite it and you rewrite it. At least I hope that you do. So maybe he then added some of these other words around there. And maybe he added that word gurgling. And maybe he rewrote and added some more words and some more words. And if he did that sequence of editing steps, that would then create the text that he wrote in his famous book, Moby Dick. Now, we don't know exactly that he did that, but we do know that these white words indeed were words that he'd written in the margin of that book, and that these words that he wrote in Moby Dick might have come around there. It'd be nice if we could read those other erased words too. We need to get some better sensing information for that. We're also looking at some other things that some human experts have analyzed, and that there are words that he used quite often that have to talk with royalty. And he was reading those words, and he was using those words when writing. He then has scientific words about whales. And if we want to do comparisons between the books that he read and the books that he wrote, well, for every book that he read, we'd have an awful lot of comparisons to make, and that's an awful lot of reading and comparing to look at those individual paragraphs back and forth. So instead, that's a good place for us to bring engineering and computer science in, where we can get a computer to do that. So we can take these passages of the scientific book he was reading and what the researchers from the scholars of the humanities thinks are there. And here's some preliminary works from one of my postdocs here at LTU, where he's using a large language model, something like ChatGPT, and saying, well, what do you think? And it can say, well, here's something else which might have been a good match. Here's something else that might have been a good match. Here's something else that might have been a good match. So we can use information from computer science in order as tools to help do some of those matches and propose matches that then the people in the humanities can go back and look at and say, yeah, I think that's good. No, I don't think that's good. Yes and no. And they will then come up with some other hypotheses themselves and not have to do very careful comparisons between all those different paragraph combinations. So we're trying to figure out what parts of text influenced and how did that affect there. And also writing style. Did he have the writing style of something similar there? In your school, you may be aware that some of your professors are comparing your writing against stuff that's on the internet to see if you plagiarize. Well, we can use those same techniques to see what writing styles and things that he was comparing there. And when we find passages that matched, we send them off to the experts in the humanities, and they read them and they think about them. They're not obsolete. Computers are not replacing people. They're just supplementing and helping. And that will allow the people in the humanities to continue with their research. The next project I want to talk about is one about World War I postcards. I did this when I was in Germany at the Technical University of Dortmund on a sabbatical, working together with a computer scientist there, Gernot Fink, and a historian, Britta Bley. And we're talking about a bunch of postcards from World War I with a collection of about 6,000 cards, which have all been scanned. And there's a lot of handwritten text, written in text that you might recognize, and this old German script, which only really old people and professionals can read. It's a different type of cursive script. And they were interested in doing analysis of the text, analysis of the pictures on the postcards, which I did not get involved with, and then trying to use that to get some historical and cultural ideas about how these postcards relate to what was happening back during World War I. So here's some examples of what those postcards looked like. Pretty simple postcards, much like postcards today, nothing really surprising there. But lots of old handwriting, and they're all pretty faded, some ink that's a little bit blurry, stamps, cancellation marks, all sorts of different things. So the first thing I did to help those historians work with things is to take these postcard images and enhance it a little bit, just simply to make the text more readable. Reading handwritten text is still very difficult for machines, and reading faded text is difficult for humans, so we can at least make the faded text easier to read. Next thing they wanted to look at was all these cancellation marks. Cancellation marks say something about where and when it was sent. Well, we know that they were all circles at that time, so I can use some image processing algorithms to extract circles. And then with that, we can extract those different cancellation marks. But notice that a lot of them are in very deteriorated condition, and we're not going to get a lot of information out of them. And they come in many different shapes, or many different styles to them. They're not all just one style. But several of them do have a common style, and if we can pick out ones that have a common style, we can make a template of that style and use that to pick out more that match that style. And we can say that that template has a date field in the middle and then information about where and when from the outside. And that helps us extract information when we find these types of stamps. In general, we want to take these postcards and we want to break it into several different categories. The stamps which provide the postage, the postmarks, horizontal lines, vertical lines, horizontal text, vertical text, and the text which has different colors. If we can break it into different pieces, we can then analyze each of those pieces separately. So let's look at line. Line detection is a common thing we learn how to do in image processing fields. So we can look for vertical lines, and that divides the text into two different parts of the page. We can look for horizontal lines, and that divides the text into the different pieces that were written. And we can extract these lines automatically, and that helps us divide up what's been written. If we know where to look for what's written, it's easier to find out what was written. And if we know where those lines are, we can also remove those lines, making the text that was written a little bit easier to read, because it's not being mixed in with the lines that were there. The stamps and postmarks are interesting things. The stamps are very colorful, but they've been deteriorated because of the postmarks. Well, using image processing techniques, we can remove the postmarks. Now we can have a clear picture of those stamps, and they're really pretty to look at. But another interesting thing there is that it really is not those postage stamps we care about. We care about the cancellation marks because that tells us this particular one was sent from Jerusalem on the 16th of April, 1911. Here's another example. Again, we can remove the postmark, or we can remove the stamp and see that this was sent from Baden in southwest Germany. Another example, just because they're fun to look at. So those are fun things to look at, and they provide information which helps our researchers. The text, we can find text that's a different color than the postmarks, and we can then separate the different pieces from each other, and again have the different things to look at, and then it makes it easier to try and read them either by humans or by machines. And the next project I want to talk about is one we call retypograph. This was done with my partners in France. Bart Lameroy is a computer scientist, and Thomas Watt Marchand is an artist who's designing new type styles. So on your computer, if you make a PowerPoint presentation or something in Word, you've got lots and lots of different styles of type to use, different fonts. They didn't just appear miraculously. Somebody similar to Thomas actually created them. Everyone was designed by a specific artist. And he was studying them as to how they were created historically. And historically, the really old type styles were printed on old-fashioned printing presses, one where you push down hard in order to make the type. And what was being pushed down were these little tiny lead blocks, which were then inked and pushed onto the paper. And that's what made all these pages in old books. Well, over time, those lead pieces were melted down. We stopped using that type of printing press. We don't have them anymore. But we do still have these old pages from the books. And by using a little bit of image processing magic, we can virtually reconstruct old pieces of type. And more than the physical old type, we really care about the shape of those types. And this is how you call it their font. That allows you to create their sizes. And with this mathematical information for those strokes, we can then compare it across different type styles. And we want to use this to be able to do an analysis of the development trends, be able to create new prints that look old, and to do some analysis of what were they doing as they were selling that type back a couple centuries ago. So if we take this example from a book printed in 1598, we can see that what was there is really low resolution scanned and not really in good condition. We've got broken letters around that M. We've got a little bit of noise in the middle of that A. But we can go through and use image processing techniques to separate out each individual letter that's in that page. And if we do that, we can say, for instance, take all the D's that are in that page, and we can combine them. And if we combine them, eventually we can get down to one character from which we can form a template. And with that, we can say what the style is for that letter in that particular typeface. Well, along the way, we made some observations that not all the D's were really the same. They have some differences, even though they were all printed on the same page at the same time in history. That the shapes of the flags at the bottom of the letter are different shapes. Sometimes they're long, sometimes they're short, sometimes they're flat, sometimes they're diagonal. And the flags at the tops of the letters are also different. So there's a lot of differences among those letters, even though they're printed at the same time. That led us to have the analysis that the printers did not just buy types that were all matching. They bought sometimes a little of this, a little bit of that, and sometimes replaced their characters when it's just a partial set of type, not a full set of type. We've got a lot of other things to use in this quest. We're not done with this project, but we know that the styles should all have the same types of serifs, those little flags at the top, and the spacing between the characters. We should be able to measure what those are so we know how far apart to put them. And we should be able to figure out where the bottom of the characters are and the tops of the characters when they're the short characters like the N and the X, which we call X height characters. And then that'll help us align them vertically. We've got a lot more work to do of pulling those pieces together. But here's an example of what we want to be able to do. Take this old piece of type, do some optical character recognition to say what are all those letters. But we can see that there's letters here like the fifth one in this line of text here, which is what we call a long S. That's a type of S that was used in the beginning or the middle of a word back centuries ago, instead of using the S as in M-A-I-S on the word below there at the ends of words. And we see there's several other things. Here's a UN that this right here, that they used to use V's instead of U's. So some different type style conventions that were not common today. So we need to first start by getting rid of those type things. So we can take this, we can first update and modernize our text by replacing it to modern text that we use today. We can then change it from a French that was written centuries ago, which is a different style. If you look at the words, they would use different words back then than we might use today. And I'm sure you see that also in your Indian languages. And we can then also translate it into English, which now makes this text accessible to people around the world. I bet very few of you on this call can read French. I only have a little bit of knowledge of French and certainly not Old French, but I'm pretty good with English, as are a lot of people who are scientific around the world. So this text here is something which you can now access and actually use and read and appreciate. But it looks pretty modern here. It does not look like some text from several centuries ago. But if I were to reprint it virtually, using the fonts that were used centuries ago, with a little bit of image degradation to make it look old, now you could actually say, well, this looks like an old book. You have a feeling for it being an old book, and maybe your approach to reading it would be a little bit different. So these are some ideas we call diplomatic translations. And it's something which is pretty commonly done and used for having people have a different appreciation of old books. And from here, we can also do some analysis of the fonts that were used across the different books and how that was changing as printing spread all over Europe and then around the world. And we can make the text more accessible to more people. So this was an interesting project, and this is still actually ongoing, and a lot of the work I'm doing in Sweden is contributing to this. And the last project I want to talk to you about in detail is on the book called Historia Scholastica, which I'm doing with a history professor in Boise, Idaho, my old university. The content of this book was written in the 1170s, long time ago. And most of the books are that old, at least from Central Europe, have something to do with the Bible, because at the time, the few people who could read cared mostly about religion. And over time, this was rewritten and rewritten and eventually printed. And so we have a copy of this book printed in the 15th century sitting in our library in Idaho. It's the oldest physical book in the state of Idaho. It was not written or printed in Idaho, but it was bought by somebody, brought back to Idaho, and donated to our library. It's written in the language of Latin, and it has a lot of scribal abbreviations. And our goal is to transcribe or recognize the text in there, translate it from Latin to English, get some more connection to the printer. And of some of the recent work I've done the last month, actually, we do have a very clear idea of that printer now. Some other interesting work there. And then use this to compare across different editions. Just like your circuits book might be on the 10th edition of that circuits book with little changes from edition to edition, every time this got copied, it got changed a little bit. And so we want to know what was changed from edition to edition, which will tell us about how things were interpreted over time. And then that will give us more information about the original editions. So here's an example of what that book looks like. It was one of those examples I showed early on of historical books. As was common in the 15th century, was to have these large drop cap letters in the very beginning of a chapter would have all this extra decoration to go with it. Sometimes these were embossed in gold. This particular edition just has 4 colors. And then at the beginning of different sections, they'd have a drop cap in a single color and a little bit of information showing that it was a section title. You can also see some little red information there. And so we've got those illuminated capitals and the drop caps. And sometimes they're red, sometimes they were blue. And we can see the rubrication, which is an old Latin word ruby for red, and the marking of the chapter titles. So these are very common features throughout the book. And a lot of these little red marks here simply show that we've got capital letters. They would then just add those. So the black stuff was printed by a printing press, and the red was written by hand onto each of those capital letters. And there's cases where they missed some. But something else that was common at the time, as well as pre-printing with the scribes, is that a lot of the letters would be touching each other. And that makes it very, very hard to extract those letters because we got to put a dividing line between the V and the O. We can't just simply say what the individual letters are. A lot of index scripts are that way too, where they touch. And some of the work that I had a PhD student do has found a way around that. And I've applied that to this book here, taking techniques that were learned for reading of index scripts to use to read a European script. In the book, they also used a lot of abbreviations because before the paper was imported from China, all the books were printed on parchment made from animal hide. And in order to get parchment from an animal hide, you needed to have an animal, and that was rather expensive. And only rich people could afford books before they were available on paper instead of parchment. And printing also cut down the cost of books. And while this was printed on paper by a machine, it was still expected culturally that it would be printed to look just like it had been written by a scribe, just as if they'd had money, but now they didn't have to need that much money. So abbreviations were used. So QUOD was written with 2 letters. PER was written with 1 symbol. IDS, 2 words and 5 letters and 6 positions, could be written with 1 symbol. So that reduced how much space was needed. Through some image, create the different pieces there. That helps us to extract where are the rubricated letters, so where are the capitals, where are the chapter beginnings, where are the drop caps, and these illuminated characters. We can segment the book into the 2 different columns. We know where the words are, we can put them together, and we know we need to read from the top down to the bottom, from the top down to the bottom. So now we know reading order, and we can segment into the individual lines of text. And we can also do some image processing. Here you can see I've fixed the perspective distortion. So the columns actually are rectangular, whereas in the second image, the columns were not rectangular. And so now we can have things as if we were looking straight down on the book. So good old image processing techniques, applying a lot of mathematical algorithms, can help us to read this book and make this book better for display to other people who might want to read it. And again, here's some information about that technique which my PhD student developed for reading the Bangla script, where we look through and we say, okay, let's just break it down letter by letter in the alphabet. Are there any A's in this word? No. Are there any B's in this word? No. C's? Nope. D? Yes, we have a D. We can go through the entire alphabet. In this example, it's the English one, but we've applied it to several other scripts, Indic scripts, Korean script, and we're using it to the old scripts as well as the new one. We can therefore identify all the letters present in the word and put those letters together, and we now know what those letters are. And this does not matter if characters are broken or touching. We can still find those around in our word. And a G is a little bit more probable than a C. A C would be found also, but the G would be more probable than the C if we look at the results from the classifier, and therefore G would ultimately be chosen for this particular example. Applying that same technique with just a simple YOLO classifier, we can find different letters that are in this old printing. And here's an example where it found an O that was touching to a T or an A that was touching to an R. It doesn't matter that they are touching. We can still find them with this method. And if we do this letter by letter, finding all the letters in our book, we can then find out everything that was printed in the book. And we'll eventually work our way through and extract that and recognize and then translate the whole book. Ultimately, our goal is to make a nice display, which can make this book very, very accessible to a lot of people, instead of right now where it's stored behind a locked door in the library because it's a very old and valuable book. But with those images and then the accessibility of translating it, we can also then display information about the history about it, talking more about the fonts, about the styles, and about the individual content in the book. So those are the 4 projects I want to talk to you about, although I've got another one I'm going to add on to the end, which is very recent from one of my postdocs here at Luleå, with those same sorts of historical images. It's really fun work I thought you might find interesting, where he's extracting images from those books, and then we can use that to say some user wants to know which images have pictures of 3 people. Well, with those images, if we know what's in those images, we can then search and we can then pull out images that have just 3 people. So that's some work that we're doing. And then with that, we're looking at another historical book, contemporary to the Historia Scholastica. And we can take, for instance, this top left image. And with that image, we can recognize the text and we can translate the text. But we can also then extract the different characters, the different people that are in the text. We can, from the text, say what was happening in this picture, and we can come up with some pose sequences. We can then use that to animate our character and have the character move around and act out what is happening in the text. Now, right now, he's not acting out what was in this text. He's just doing some rather random work just to illustrate the fact that we can illustrate him. We still need to plan out the pose sequences. And actually, we've got a colleague in Bangladesh who has a group of students who want to help us with this by acting out some of those poses to help give us some of these stick figures that we're going to need to animate the characters. So lots of teams can work together and we can get lots of interesting stuff together. And I just thought I'd share this extra thing because it's kind of fun. But this was fun work because we can see a dancing man. But we can also use some of these same techniques for doing serious scientific projects. We're trying to extract vehicles taken imaged by a drone. And some of them will have snow on top for Arctic driving, and we can use some of those same techniques, which will then help us detect those images and work with those for Arctic driving and analysis. We can analyze cars and make driving safer up here in the north when we get a lot of snow. And we can also use those same techniques to extract information about skiers and other sport people. And we can, again, with that same pose generation and animation, we can use that to animate and help give feedback to our skiers so that they can then improve their technique. And we're hoping that'll help them win more medals in various skiing competitions. So that fun work we can do with a document to help people in the humanities learn more about their books and make those books more accessible to everyday non-scholars can also be used for scientific and other purposes as well. And tying it across the different disciplines, I think, is really a spectacular thing where we can use the same technique for the humanities and for other purposes. So overall, I hope you find this an interesting introduction to the digital humanities, where you've now learned about several different projects that I've worked on, and maybe that gives you some ideas from other projects you could work on. You can see that AI and engineering, computer science can really help these researchers with their projects in the humanities. And I feel that we can together take AI, engineering, computer science, merge it with the humanities. And when we do that, we can have a nice, happier Earth we can all live on together. So if you want to know more, I had a TED Talk that you can get more information about some of these and some other projects I've worked on. And I want to thank you very much for inviting me to talk with you. And we will open it up to questions now As your host said, he's collected some already, and I'm very eager to hear what other ideas you have and hope this has inspired you for some things in your future life. Thank you again for inviting me.
Thank you, Professor, for your insightful discussion. Now, before I go to question and answer session, I would like Abdullah Fahim, the chair of our student branch, to say something.
Thank you, Professor, for your excellent presentation. Uh, in your presentation, I have seen you are still doing some project which is ongoing. So I hope if any one of us work on this project and work on this topic may reach to you and you respond us as early so that we can work with you maybe in future. Now, I would like to share our counselor, sir, MD Amda Hussain, Doctor, Professor, Doctor Engineer. He has been on Germany, he has been on USA, he has a vast experienced person. So I would like to invite him to show you some gratitude. Sir, if you are here, please unmute yourself. Sir? Okay, maybe sir is not responding right now. We can. I request our host to move on to the questions session. Sir will add later.
Okay.
I'm sure professors have a lot of busy things to do.
Thank you. Now, before I go to the question and answer session, a professor talked about Melville's Marginalia and Historia Scholastica. They were very interesting projects, and she talked about Moby Dick. I also, not very long ago, read it, and it was very insightful. It was very enjoyable. Now, I'd like to move on to the question and answer session. Okay, this is our first question. What ethical considerations should be prioritized in the development of emerging technologies in electrical engineering or computer science? And how can insights from humanities guide this consideration?
Well, you should always be thinking about what the effects of things are. If you're going to be looking at anything that's in the humanities, it's attached to a culture, and you need to have respect for that culture. I should not come in to India, grab some of your text without understanding its cultural value and how it fits in with everything else that you're doing. And that's why it's really important to me that I am working together with the people in the humanities such that I have permission from them to work with these documents, and they have a much better cultural understanding about where these different things fit in. So, consider what the purposes are for them and what their original purpose was when they were produced and how that affects the cultures that are still around today.
Thank you. Our next question is, what technical skills would you recommend for humanities students who want to work in interdisciplinary projects with computer science or engineering? I think this question goes the other ways too. What do you recommend for an engineering student or computer science student for if you want to do interdisciplinary work?
Knowledge of more languages, or at least awareness of them, is very, very good. A lot of people in the United States have no idea that there's any other scripts other than the ABC we use for English. If you grow up any place outside the United States, that's a little bit more visible to your day-to-day life. But being aware of what's out there, reading a lot on your own. You cannot read everything that's out there. Getting a general information about literature and history is good. You don't need to be an expert at it. That's why we've got the people in the humanities. Technical skills for people in the humanities. a very general understanding of computing and programming. You do not need to be an expert, but the more you know about, the more you know what might be possible and what things to ask. One of the hardest things has always been starting the project, where we have to come together with me and my colleagues and make sure that we understand each other, that I understand what they're looking for, and that they understand when I say I can do this, this, and this, what it is that I say that I can do, such that we can then make sure that I'm developing something that's of use to them, and that they know that they're not asking for something. It's like, no, you can't do that. That is not possible. So general computing skills are useful, but again, humanities people do not need to be an expert at that. Awareness, though, is extremely valuable, and everybody should be aware of things outside of your narrow field.
Thank you. Our next question is, are ethical considerations rooted in humanities becoming less significant as fields like electrical engineering, computer science, especially artificial intelligence, continue to advance and develop their own ethical frameworks?
No, because I think that the problem, every problem, there's just more problems, and everything you're trying to do has its own ethical consideration. So the considerations for the humanity remain significant as we're looking at things from there, but in addition, we're adding one more to it. You can kind of think about it if you're looking at a family. You know, when a family has their first child, they love that child, and how much love they have for that child is there. When they have a second child, they don't stop loving the first one and reduce the amount of loving for the first one in order to love the second. So we have the ethics that are needed for the humanities, and now we're just adding to it that there also are ethical issues for the technology, something which has really been around for a long time but has not been emphasized. And it's really thrilling to hear young people like you having two questions already that have something to do with ethics, that you're at least aware that this is something that you should be considering and thinking about in your work and in other people's work.
That was a great analogy. Thank you. Our next question is, what role does AI play in bridging the gap between engineering and humanities? For example, analyzing literature, art, and historical data.
Well, yes, I gave you several examples in my presentation where it does help. We're never going to take the people of the humanities away, as I showed with the example with analyzing the Herman Melville work. The computers can accelerate and make some of the work a little bit less tedious, but we are always going to need the human in the loop. We're going to need to have the expert's going to be the person in the humanities. Their job is not going to be replaced by the AI and the technology, but it will help give them more tools to analyze it in a different way. I did not talk about another related project we've got going with Melville, where we are looking at sentiment analysis. Is a particular sentence expressing anger or joy or sadness? And we can look at the sentiment. And another person from our team who's moved on to another university has taken some books and looked at the sentiment analysis from the beginning to the end. And that's only possible because we've got the text OCR. And then because we have the marginalia marked, he can then say, well, where is the sentiment when we have the marginalia? So it provides more ability to do different analysis that was not available before. And like I said, it allows us to do a lot more of the analysis because we can go through a lot more data and then provide a smaller amount to focus the efforts of the people in the humanities.
Our next question is, what are the contribution of electrical engineers in the green development of green technology? I don't think it's relevant, but if you want to answer, sure.
Well, there's one of the cities just 2.5 hours south of here, Skellefteå, Sweden, has a very large battery plant, and that is developing batteries for electric vehicles. And so electrical engineers are doing a lot of work with that. developing techniques so that all these batteries in your cell phone and your laptop and these cars are charged most efficiently so that the charge lasts the longest and the batteries stay healthy the longest. So those are just a couple really quick ones, basing on something which is really local to us here in Sweden. Sweden spends an awful lot of time on green technologies and tries really hard to do things with there. So there's lots and lots of places, if any of the people online are interested in that, there's lots of places you can apply electrical engineering into development of green technology.
Mm-hmm. Thank you. And I can already see that the counselor of our branch, Mohammad Amjad Hossain, Dr. Engineer, he has arrived among us, and I'd like him to invite and say something and present the token of appreciation to Dr. Smith. Please, sir.
Thank you very much, Professor Elisa. We are really sending our thanks to you, the IEEE distinguished professors, Joshua University of Science and Technology. Really thanks to you. So I am going to send a token of appreciation, Dr. Elisa Barney Smith, IEEE distinguished visitor and machine learning professor, Luleå University of Technology, Sweden, for being the speaker of the event named Applying Electrical Engineering and Computer Science to the Humanities.
Thank you very much.
So I think this is a very good presentation. Our students, they learned a lot of things from your presentations. So in future, we will again request you for more presentations for the benefit of our students.
It's great that there's so many excited students out there.
We are really appreciating your presentation. So a big hand for you. Thank you very much for your presentation again.
Thank you for having me. And thank you for, I know it's quite late in India right now, so thank you for, on a Friday evening, putting time into your schooling and your profession.
Thank you, sir. Thank you, ma'am. Ratul, please carry on.
Okay. Even though this event is organized by two organizations, I am from IEEE Just Student Branch, and our another organization is IEEE Prime University Student Branch. Now, I'd like to invite Azmi A. Fatehi from IEEE Prime University Student Branch to say something.
Hello, Dr. Elisa Barney. Can you hear me?
Yes, I can.
Okay, so I was so interested about that session. I have heard one of your interviews in TEDx Talks. At that video, you were talking about how digital technology helps solve mysteries in the humanities. And at that video, you talked about a topic, how the introvert and the extrovert engineers are, and that was an amazing topic. I loved a lot at that video, and this illustration was so good. So I have several questions about that. Dr. Barney, your work in image processing and machine learning had such a profound impact. To start us off, could you tell us a bit about your first become interested in this field? What sparked your passion for?
What sparked my passion for electrical engineering or for the application?
For working for image processing or machine learning.
Well, I started off as a computer science student, and then I went into electrical engineering, and it just always, I'm very visual. I like drawing. I like seeing things, and so image processing was a very interesting thing to do when I was exposed to that as a course when I was a graduate student. Prior, when I was an undergraduate student, we did not have graphic terminals, so you couldn't do digital image processing. But that's graphic terminals came to be, then that became a topic, and it was a really interesting course. And with machine learning probability, the course on probability and statistics, I found a very, very interesting course. The idea that you can work with something you don't know, the uncertainty. And my first job after my college career, before I got my doctorate, was working with doing detection theory. So again, trying to extract something from the unknown. And just working with the unknown then leads into the machine learning, and how can we have the machines help us to extract knowledge and information, idea from the unknown. And it's been very fun to work with. It's helped that I've found lots of interesting things to do with it. It's the applications that I've been able to work with have always been very interesting. And that's just provided me the motivation to do more and more and more.
Okay, so I have one more question. I have visited your LinkedIn profile, and at there, it's been included that you have been working from signal processing. Can you tell us something about what you are working on at that topic or at that sector?
Well, right now, the signal processing I do is mostly the two-dimensional signal processing, which is image processing. And that's the manipulation of images. I showed some of the stuff with the enhancement of the postcards and the perspective distortion for the book images, segmenting the characters. All of that is image processing. Prior to that, I did a lot of work with underwater acoustics, and detecting objects in there. So there's a lot of work also with that. Signals that are appearing in some of the neuromorphic computing. I worked with some signal processing for that. So those are just some of the places I've applied signal processing over time. But remember that image processing is just two-dimensional signal processing. The stuff you take in your undergraduate course is usually one-dimensional signal processing because they want to start you off with the easy stuff. And one dimension is easier than two dimensions.
Okay, so thank you so much for your insightful presentation today. It was a pleasure listening to your expertise, and I'm sure we're all gain a valuable knowledge today. Wishing you all the best, and I will look forward following your work. Thank you so much.
Okay.
Thank you, Azmi, for your great questions. Now, Professor, I would like to ask another last question that I got from the chat section. The question goes like, can we fabricate human signature by image processing? And if yes, is it harmful to use as it can create chaos in our society?
Yes, you can. We've got a lot of work that's on creating synthetic text that's in the writing style of somebody. For signatures, you can definitely lift a signature that's someplace and plop it into another document. That's really easy to do. You don't need to really create it. You can just copy and paste it. If you're trying to sign something at a store on one of those little tablet devices, that's a little bit harder to fake when you're looking at the speed as well as the shape of the word. So there's those problems. And yes, right now, I think one of the big problems that's out there, there's a lot of deep fakes. That's not necessarily signatures, but deep fakes of other images and movies, and some of the bad things that those are being used for. So there's definitely ethical considerations there. I would say a lot more of it comes as to how people choose to use it. Even social media, if it's used well, it can connect people. Azmi said she went to my LinkedIn profile to learn more about me. So there was a good use of social media. But we see in politics where social media is being used for some bad things and for spreading misinformation. So all technologies can have a positive side and a negative side. And it's up to you, particularly all of us, but particularly you, the upcoming generation, to try and use it for a good purpose and help educate the other people around you as to what's good and what's bad and how to use it for good purposes, and convince people to use it for good purposes. There'll always be bad people out there. They'll always find a new thing to do that's not good. But if all of you are good and you can help other people to be good and you can use the technology for good things, the good can overtake.
Thank you, Professor, for this amazing discussion with us. And it's people like you who research and enthusiasm to inform other people like us about this research. These things will inspire us to do great things in technology and humanity. Thank you, Professor, again. Thank you, everyone. We are officially ending this session.
Thank you again for inviting me and for staying up late to attend.
Don't worry, it's only 10:42 p.m. here. So we basically sleep at around 12. So it's been 1 more hour left. So I hope that's all okay. And I'm really happy that you have accepted our invitation. And I hope I will invite you future for more session from you. And this is excellent. This has been really excellent, and I'm really happy for this session today. And I will send you the token of appreciation to your email address, and I hope you can share it, and you can tell that there is a student branch in Bangladesh in Joshua University of Science and Technology student branch. Also, there is a Prime University student branch in Bangladesh who are working hardly for IEEE and for the engaging the network and capacity building the network. Okay, thank you, Professor, for your time. Good luck and best wishes from our branches.
Thank you.
Bye.
Goodbye. Thank you very much.
Thank you, sir, for being here.